Hello there everyone, it's Malcolm Budden here from MNB Networks. I've just had a conversation with somebody and it made me think that I want to do a quick video to explain the differences between a few different things, specifically in regard to types of SDN networks or software defined networks, types of SDN, because I think that where we are now as an industry is people are actually starting to embrace software-defined networking, which is what this acronym stands for if you don't know already. But I want to put some context around what software-defined networking is, and it's not one thing, right? There's so many different pillars to it and aspects to it that you need to consider if you're looking to transform your network and modernize your network. And we've went from like software defined WAN, SD-WAN, and that really just being a buzzword to going way back to sort of 2015, 2016 to now we've got SD-WAN, SD-LAN, automation, buzzwords like controllers, orchestrators, automation engines. It's just really confusing for end customers, and I don't think that some of the marketing stuff that's out there actually helps very much. So I'm going to try and first of all, probably in this video, I've only got time to talk about the different types of software-defined networking and give some examples. So if we've got SD-WAN, right, this is the software-defined networking that I'm most familiar with. How I'm going to explain this is in the differences between software-defined WAN and traditional WAN. Traditional WAN are things like MPLS, and that could be layer 2 or layer 3, VPN, for example. That is basically where you've got the cloud, which is provided by the service provider, and then you've got sites that are connected to it, like this. And then these sites can communicate with each other, like that, any to any, or they might have to go through a certain hub site like this to talk to another site. So everything is dependent on this one, and there's also the capability to do point-to-point circuits between the sites if you have very bespoke requirements, and you can also have things like physical cables going between, but that's not MPLS, right? So that's traditional WAN MPLS. We've also got internet-based internet VPN. So that's kind of similar to what you see here, but if I draw a different coloured cloud like this, you've still got that physical connectivity to the internet, but you're connected to, every site is connected to some VPN, and the traffic flows might be any to any, or they might be via a hub, just like I explained before. Then you might also have, for example, point-to-point links, which I mentioned down here. When we go to SD-WAN, it's similar to this internet VPN based topology, but in software-defined WAN, what we have is typically orchestrator, which manages the control plane being the routing. But what I'm actually really surprised at, just from some observations, and this wasn't the conversation today, but it's conversations that I've had with customers who have purchased SD-WAN solutions and they don't really understand what they've bought or why it's different. Now, why SD-WAN is very different is it's actually much more complicated than traditional WAN, because traditional WAN was around getting stuff from A to B. With SD-WAN, we've got different components that sit centrally, which I'm going to say the orchestrator is up here. And then you might have another device, which is a gateway, which goes to other networks, like the internet, for example. So anyway, these are connected in the data center and the data center could be the cloud or whatever. But then what we actually have in the SD-WAN environment is we might have one or all of, or some or all of these that makes up the SD-WAN. And what people always seem to struggle with the fact is if you have, like, for example, MPLS like this, and then you have sites physically connected to the MPLS. Traditionally, these sites would be able to communicate directly over the MPLS, but the service provider would see all the routes in their routing table. When we've got SD-WAN, we have an overlay network where the site is connected. So similar to what I had in this picture here, but this blue traffic flow that you see here is actually a tunnel that's being created between these two sites. Now, if that's via MPLS, and they're both connected physically to MPLS, and this data center is connected physically to the MPLS, and then they're all connected to the green overlay, then that's great. You're on the same transport effectively underneath the SD-WAN. If you're actually got another site which is connected to the internet like this, so if this is site 3, 2, and 1, and site 3 connects to the internet, which the internet is one of these other networks, then what do you think the traffic flow is going to be for site 1 to connect to site 3? Do you think it can go directly over the MPLS, over the internet? Well, maybe. It depends on if you're using the same service provider and what product. But the reality is that the traffic flow for these sites to talk to each other will be like this. Now, that has all sorts of different things that you need to consider, like SLAs. What's the SLA? So if you need an end-to-end no packet loss or 0.1% packet loss, and then also 50 milliseconds latency and whatever your jitter threshold is, then are you going to be able to get that in that path? Probably not. Are you going to be able to achieve it technically? Probably, or maybe, depending on the grade of the internet service, but part of your network there has basically been carved out into, like, there's no SLA there, right? So that's one of the things that you need to remember about SD-WAN. But also, like, when you've got these orchestration tools and the gateways and things like that, they are more things to manage. And then in addition to the overlay, which is the green thing here, plus multiple transports, there's a lot of different components with SD-WAN. So that's why if you're considering SD-WAN, then you really need to either know what you're buying and understand it, or have a good partner or supplier that's going to help you understand it. So that's just SD-WAN. Millions of things that we can talk about there, but we don't have time in this particular video. So I'm going to crack on to the next type of software-defined network, which is SD-LAN. Right, so SD-LAN is a similar kind of concept where you've got switches, right, in your campus, and you would traditionally have had, like, the core or a collapsed core. These would be some kind of layer 3 switch, and then you'd have your layer 3 gateways here, and then this is just an access layer switch, which are on VLAN 10. This might be VLAN 20 if it was a different default gateway or something like that. Or it could be a shared VLAN or whatever. And then we have, like, multiple, like, VLANs on the access layer, right? Now what we're talking about is also putting, like, using the same methodology, but making these access layer switches layer 3. So they're layer 3 as well, and then surprise, surprise, we then create an overlay which the access switches are connected to, or part of a fabric, and then you add more access layer switches. And then there's lots of benefits that can come along with software-defined networking, but you can also then connect access points into this and have that as part of like one big fabric. So what does a fabric mean? It means even though you're separated potentially from layer 3 in the underlay, you've got an overlay on the top of the network that makes it look like you're all connected to the same subnet or the same SSID between sites or between buildings or whatever it is in your campus LAN. Okay, so again, the similar kinds of things where we have SDN controller or orchestrator for SD-LAN, and that's normally a separate. So if that's number one, that's number two. So you can see now that we've got SD-WAN and then we've got SD-LAN and we've got two orchestration engines that are completely separate from each other, or two SDN controllers that are two separate or completely separate from each other, I should say. And then all this additional complexity and overlays and routing to the access layer instead of layer 2 and all that. So something to consider. The next thing that we've got is software-defined data center. Now, software-defined data center is if we take a spine leaf here, a spine leaf scenario, like you see I've drawn out, everything is dual homed, and then that's data center 1, and then let's say this is only the hosting environment, by the way. So let's say if we then have, that's DC1, and then we've got DC2, which has leaf nodes as shown. Everything's dual homed from the spine and leaf. So then what we have is potentially some data center interconnect routers, and these might be the border leafs, which are the way to get out of this fabric. And yep, you guessed it, there's typically an overlay inside here, which in this scenario is VXLAN. There's VXLAN here typically in the campus too, by the way. So you can see we've got a mix of VXLAN. This is multi-point GRE sometimes, or sometimes proprietary protocols from vendors. So we've got multi-point GRE, VXLAN, potentially like Lisp. Here we've got VXLAN as well. So if this is VXLAN and Lisp, potentially this might be VXLAN and BGP EVPN, and then also BGP eBGP underlay. Right, so we've got BGP running in the underlay. Now what we might have is if this is like EVPN between effectively these border leaf nodes, right, running over like, and this is like a normal IP transport. So you've got an IP transport underlay with BGP EVPN running over the top and VXLAN running either side of it. Now, that's three different types of software-defined networks. Now, if we park that to the side, there's other things. There's like the other things that we're talking about in modern networks are AI and analytics. We're talking about telemetry and real-time telemetry being near real-time reporting on how the network is performing. We're also talking about automation and scripting. So this could be like if you're running a Python script to do a network discovery and bring all your devices back into an open source tool. It could be I need to roll out the SNMP strings in a multi-vendor network. It might be I need to do some other change, 802.1x, which actually that is now becoming a hot topic as well. So microsegmentation. If you look at segmentation, if you look at microsegmentation and how difficult it is to implement historically, you know that that's quite a challenge. But there are now overlay-based solutions and integrated-based solutions that are coming into the marketplace that are saying that they can simplify all this. So on that note, I feel like I've only just scratched the surface. However, on that note, we have three main types of software-defined networks: SD-WAN, SD-LAN, software-defined data center. All of these have their own orchestration platforms and software-defined network controllers. But we can also give this like rich intelligence that we have here in modern day networks with artificial intelligence, detailed analytics on how the network is being used and what applications are being used. Also, we can automate and script things if it's not perhaps covered by the SDN controller. And there's more and more requirement coming for microsegmentation, especially in like IT, between IT and OT. And that's really like something that's always been a challenge. And I'm quite interested to see how the landscape evolves in that space over the next few years. But this is to give you an idea of like what we're dealing with. This is where networking is going. You've got a mix of underlay and overlay technologies, a lot of additional complexity, a lot of different solutions and requirements that are just being expected by the business, and it's all needs to work together seamlessly. I just thought that was worth putting a quick video together to shine some light on the networking industry and the state that it's in these days. And I don't mean that in a bad way. I just mean that don't underestimate how complex the job of a network engineer is. We also have specialists in each of these specific areas. So although somebody might be a proficient network engineer across all protocols, they might not be an expert in SD-WAN, SD-LAN, and SDDC, software-defined data center, and all the underlay transport technologies that come along with it. So, yeah, hopefully that was an informative video for you. It just came on the back of a discussion that I had with somebody, and I thought it was worth bringing it up to highlight where we are as a networking industry. Okay, thanks for listening. Hope you enjoyed it. Cheers.